Oh wow, there's a hole in the bottom of the ocean. It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960. And it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia. A road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found, hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn!
In November 2020, a wave the height of a 4-story building was recorded off the coast of Vancouver Island, Canada. The team at Marine Labs, the company that operates the buoy that got caught in it, couldn't believe the data they saw. Everything was normal, then, unexpectedly, a vast force came, pulled the buoy down, and then sent it up to a peak before taking it even deeper. The probability for such a huge wave to form is once in 1,300 years, so they had to be sure it wasn't a technical mistake. Marine Labs sent the data to a rogue wave scientist at the University of Vancouver. They analyzed and validated the findings and shared them in February 2022. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Luckily, this giant didn't leave any damage, as it happened too far offshore. For centuries, rogue waves were believed to be real only in the stories of sailors. Christopher Columbus himself mentioned a rogue wave, but back then, it wasn't officially a thing. In August 1498, he was on his 3rd expedition to the Americas. As they were passing through a strait near Trinidad, a huge wave lifted the boats. They managed to survive and continue the journey, and the area is still known as the Mouths of the Dragon, named this way by Columbus. Back in 1826, A French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got caught in a terrible storm and witnessed several waves over 80 feet tall. One of them was the height of a 10-story building. The crew lost one of its members, but the four of them, including the captain, made it to land and spread the story of the gigantic waves. But back then, scientists were sure waves couldn't be taller than 30 feet. So everyone took this story as a tale. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This sea monster of the North Sea hit the Norwegian gas platform Draupner on New Year's Day. It reached a height of 84 feet. The waves surrounding it were twice as small. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. It became a sensation in the scientific world because it wasn't like any other type of wave they'd studied before. So they gave rogue waves an official definition. It's a wave more than twice as tall as others around it. These bad boys, also known as freak waves, monster waves, and episodic waves, can pop up lightning fast in a stormy sea or show up out of nowhere in calm waters. They have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters just trying to do their job. Rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Scientists and sailors singled out some statistics. Rogue waves more often form when wave trains run into fast ocean currents. The coast of South Africa is one good place for that. There are concerns that these water beasts may happen more often in the future because there's more energy in the atmosphere and ocean. It means larger and more frequent rogue waves and more ships lost at sea. Rogue waves aren't limited to oceans and can even occur in lakes. Lake Superior witnesses something that got the name Three Sisters. It's a series of three large waves, one after another. The second wave covers the ship decks before the first one is gone. The third wave jumps in and adds extra water. These three sisters overload the ship. There's a theory that this phenomenon took down the steamship Edmund Fitzgerald in 1975. Rogue waves are also dangerous because they form rogue holes in the water. When the wave builds up, it draws in all the water around it. So, near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the notorious Bermuda Triangle in the Atlantic Ocean. Storms from several directions converge in this mysterious area, so rogue waves are more likely to gain force here. And because they can reach a height of 100 feet, they can theoretically bring down an airplane, not just ships. There are two main theories trying to make sense of how rogue waves happen. First up, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. Now, when these waves cross paths, they team up and become stronger, cooking up a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they share some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and toss it into a fancy math model that paints a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but as scientists measure more rogue waves, mathematicians may find a way to alert us of the upcoming rogue waves rising out of the water. Sometimes you can hear the term sneaker wave as a synonym for rogue waves, but oceanographers claim there's a difference. Rogue waves occur mostly in the ocean, and sneaker waves build up at the shore. They're also known as king waves and sleeper waves, and they roll up much faster than usual waves when they approach the beach. They always appear without warning after smaller waves and can be powerful. They can carry swimmers further away into the ocean. But the worst part is, they can also sweep you off your feet and into the water when you're casually strolling on a jetty or the beach, or on an outcropping nearby. Oregon State University researchers found that sneaker waves form in offshore storms that carry wind energy to the ocean surface. With all that energy, several waves unite and overlap into one beast that stands higher and goes further ashore than a regular wave. Another thing that makes them more dangerous is that, just like rogue waves, they're hard to predict. Fishers, surfers, and others who spend a lot of time by the water normally know when and what to escape when it comes to big waves. With sneaker waves, that logic doesn't work. There is no set time of the year when they're more active either, but putting together some data shows you're more likely to experience one of those somewhere between April and October, and the peak would be in October and November. Sneaker waves carry huge amounts of water, sand, and gravel. Those can fill up your shoes in a matter of seconds and sweep you off your feet if you're unlucky enough to be ashore at that moment. These sea monsters also have the power to move huge logs, which carries another hazard. Now, we as human beings have faced all sorts of challenges – ice ages, tough diseases, squabbles over real estate, and so on. But let's try to go way back to 400 million years ago, to the times when our oceans were ruled by sea creatures and the lands barely had any animals on them. Do you think you'd be able to survive there? We're talking about the Devonian period. It started around 400 million years ago and lasted really long, about 60 million years. It's named after Devon, England, where scientists first studied rocks from this time. The world was quite different then. Our planet featured 3 continents, a gigantic supercontinent, Gondwana, down south, a smaller one called Siberia up north, and another medium-sized one called Laurasia to the east. These landmasses were moving around and crashing into each other, making big mountains. Now, imagine if your time machine broke down and you ended up in this ancient world. You're now in a world where the land is pretty much a barren wasteland. You are surrounded by basic plants like mosses and ferns. This is the early Devonian period. There were no trees yet, but moss was everywhere. And wow, that's a lot of water! Around 85% of the Earth was covered by oceans during the Devonian, so you see many warm, shallow, oxygen-depleted lakes around you. The first thing you notice is that breathing seems a little harder. Well, don't panic. It's all because of lower oxygen levels, around 19%. It's still enough to ignite fire, and trust me, you'll need one, but prepare to feel a bit dizzy. Luckily, there are no huge predators to run away from, but you'll probably have to do a lot of swimming. Alright, at least the weather seems pretty nice, warm and steady. If you keep traveling, you'll notice that the land seems almost limitless. That's because we're on Gondwana, the biggest supercontinent of them all. Since the tectonic plates don't move around much, there are barely any mountains around, and the Earth actually feels flat. Well, not totally flat. Gondwana boasted a gigantic mountain range, akin to the Himalayas. This range was gradually breaking down, sending sediments into the ocean. Those sediments would provide nutrients that help marine life thrive. In any case, it really feels like a whole different planet. The landscape around you looks like something out of Mars, if it had water. The only question is, where is all the life? Underwater, of course. There's a reason why Devonian is called the Age of Fishes. Now, to be fair, it wasn't all fish. The conditions were perfect for certain early marine life to develop important things, like lungs. Some even gained the ability to crawl out of the water and onto land for short periods. So, if you spot a tiny lizard-like creature around the coast, don't step on it. It's your great-great-great-great-great-grandparent. Well, it's not like you'd be able to really step on it. Remember the guy from the evolution meme with a funny crocodile-like head? His name is Tiktaalik. As you can guess, it was one of the first creatures linking fish to land. And although it might look friendly, it actually has a 9-foot-long body and very sharp teeth. And yes, it can crawl. So if you notice a huge lizard, better find a hiding spot. You'll start seeing more of those tiktaalics and four-legged animals in general by the Middle Devonian. But let's risk our lives for a moment and dive underwater. What do we have here? Welcome to Subnautica, Earth Virgin. While the land looks very primitive, marine life is incredibly diverse. We have corals, sponge-like creatures, sea lilies, shellfish that resemble clams, and more. The oceans are filled with various critters that look fascinating and potentially dangerous. Here are some tough armored placoderms, and yes, all of them are bigger than you. These formidable fish had powerful jaws with blade-like plates as teeth. They started as tiny guys who munched on mollusks, but as time went on, some turned into massive fish-slicing monsters, reaching up to 33 feet in length. The biggest of them was Heterosteus with their scary-looking eyes. This other guy, whose name Titanichthys, with its mouth always ready to swallow you. And the largest one, Dunkleosteus. Oh, those are $5 names, huh? And here are some smaller guys. These are the shark ancestors, the cartilaginous fish. They had small, rough scales, fixed fins, and sharp, replaceable teeth. And finally, there are tiny ancestors of our normal modern sea creatures, bony fish. They're nice and pretty harmless. They were covered in scales and equipped with maneuverable fins. You know what? I think you can cook this one. So the question is, how do you cook it? There are no trees for fuel around, not until the Middle Devonian at least. So you'd have to scrounge up some super dry moss and get to work rubbing rocks together. Fortunately, the warmth of the climate would save you from freezing at night. But since there's not much stuff to burn, you might be better off sticking to a raw diet of mollusks and other early arthropods. In this world of basic plant life on land and a huge ocean around, getting food and resources would be quite tough for you. Perhaps you could stick to fishing or collecting stuff from the sea. Overall, you'd have to be really clever to live off the small amount of plant life and maybe learn a thing or two from the sea creatures about navigating the oceans. In any case, you'd have to start from scratch. Surviving in the Devonian would be quite a challenge. Our bodies aren't built for living underwater or thriving in an environment dominated by early marine life. You need some shelter. Maybe you could try to build a basic house along the shores using dirt and moss, probably. You just need to create tools and shelters using whatever resources you can find. So, get creative. Also, get used to living without clothes, unless you make up a way to create a dress out of moss, seashells, and fish bones, all Little Mermaid style. Alright, to make it more fair for you, let's say you ended up closer to the late Devonian period. Hey, now things are looking up. At the end of that era, the first forest started covering our Earth. Now we had plants with spores, leaves and roots, and even the first plants with seeds. The land is slowly getting some life. Hooray to normal breathing again! We've got some little bugs, 4- and 6-legged critters. The first land vertebrates, early tetrapods, started showing up. They're pretty cool. Very early ancestors of mammals and eventually us humans. But hold on, Houston, we've got a problem. As plants started taking over the land and breaking the rocks with roots, they released tons of nutrients in the water and caused a chain reaction. The sea got filled with algae, greedy bacteria thrived, and since there was almost no oxygen in the waters, around 70 to 80% of the species vanished. Whoops. But hey, good news for you! Less oxygen-hungry predators in the water. However, now you have to watch out for your new land neighbors. Most of them aren't harmful, but it's better to watch out. But still, with more trees and plants around, you could make useful tools like spears, fishing hooks, and rope. During the end of the Devonian, you might even build yourself a tree house. Picture that, in a world with the first tree ever, reaching 90 feet tall with a super wide trunk. So, it seems like you'd be able to survive without much trouble. You might even turn into a vegetarian with all these plant options. And hey, no more itchy clothes. You could fashion something much more comfortable. And remember that dinosaurs are on their way. Until then, enjoy your time. Wow, look at this cute little cookie cutter. At first glance, it looks like an oversized anchovy, but in reality, it's an undersized shark. This shark never grows bigger than 18 to 20 inches, but it doesn't make it less dangerous than its peers. They got their sweet cookie name because they have a unique feeding strategy. They bite off small chunks from much larger animals and get away with it. These little guys live deep down in the water column, making them quite mysterious and hard to study. We don't know exactly where they hang out, but they've been spotted all over the world, especially in tropical and temperate areas. The cookie cutter shark is a total parasite. It feeds off larger animals while keeping them alive. It uses its sharp upper teeth to latch onto the skin of bigger sharks, fish, or even marine mammals. Then, with its strong lower teeth, it scoops out a mouth-sized chunk of flesh or blubber. Ow! So watch out, because even big predators like bluefin tuna, great white sharks, and spinner dolphins can end up with scars from these little sharks. Now, there's one crazy story about a cookie cutter shark biting a person. Picture this: a long-distance athlete swimming between islands in Hawaii at night, surrounded by boats with bright lights attracting prey. Yep, that swimmer got a nasty bite on the calf, leaving a gnarly scar, but luckily no permanent damage. Lesson learned: don't mess with cookie cutter sharks during their feeding frenzy. To hunt like this, they have a well-equipped mouth. The mouth itself is like a short line that goes across, surrounded by these big fleshy lips that can suck stuff up. It's got a bunch of tooth rows in its jaws, like 30 to 37 in the top and 25 to 31 in the bottom, and they increase as it gets bigger. The upper teeth are small and narrow, standing up straight with a single smooth, pointy bit. The lower teeth, on the other hand, are way bigger and wider, almost like knives, and they interlock to make a saw-like cutting edge. Just like any other shark, cookie cutters lose their teeth throughout their lives. But here's where they're different: they swallow their lost teeth. Some scientists think they do this because they live in nutrient-poor deep waters and want to recycle important tooth-building materials, like calcium. That's a brand new approach to diet supplements, huh? Since they feed closer to the surface at night and deeper during the day, they're almost always in the dark. So, this sneaky little shark has these special light-producing organs called photophores that are strategically placed on its belly. These photophores help it blend in with the light coming from above, kind of like camouflage. It's a classic move in the bioluminescent world. The cookie cutter shark also has this cool, non-glowing collar around its throat. Some scientists think this collar acts like a fancy lure, making it look like a tasty little fish from below. Imagine how irresistible that would be to a whole gang of hungry sharks. It's like a dinner invitation they can't refuse.
The Meg, aka Megalodon, roamed the oceans long after dinosaurs were wiped out by the Great Meteorite. It was one of the largest and most dangerous hunters that have ever lived on Earth, as well as the biggest shark. But then, about 3.6 million years ago, the last of its kind disappeared from our planet, leaving only huge teeth for modern archaeologists to keep finding. There are a few theories about why it could have happened, but scientists might have found the true reason. The Megalodon, which means big tooth, was the largest shark ever to exist. It reportedly lived around 20 to 3.6 million years ago and was truly enormous. Its bite was more powerful than that of a T-Rex, and likely any other powerful predator that has ever roamed this planet. It's probably not surprising, since this marine creature had extremely strong jaws that could span from 9 to 10 feet wide. That's enough to swallow 2 grown-up people side by side. The jaws were also lined with 276 teeth, and they reached 7 inches in length. That's as long as a small hedgehog. Once these teeth got worn down, the shark got rid of them and grew new ones. Such large sedated teeth helped the Meg to eat meat easily. The shark itself could grow up to 59 feet long. That's twice the length of a London double-decker bus. The animal was also pretty heavy. While a fully grown T-Rex weighed about 8 tons, The weight of a large megalodon could be more than 30 tons. With no competitors, the enormous shark was the real king of the oceans. It hunted other sharks, large fish, and even whales. Then why did such a magnificent creature disappear from the face of the earth? The previous theories mentioned the great white shark. The megalodon is usually described as some gigantic version of this marine animal. And this is a common mistake made because most people think these creatures were related. But in reality, the meg looked more like a modern bull shark. Its snout was snout, its lower jaw was rather flat, and long and massive pectoral fins supported the animal's weight. But what's more important, the ancestors of today's great whites existed at the same time as the megalodon. Now, with great size comes great clumsiness. And although the meg was huge and powerful, it was also not as nimble as smaller and quicker great white sharks. Great whites could have rivaled a megalodon for food, and were often more successful hunters thanks to their agility. They couldn't fight the meg openly, but were fast enough to steal its food. So according to this theory, the only food left for the megalodon were whales and equally big marine animals. Grown-up megs could easily catch such beasts, but their offspring were much smaller and more vulnerable than their parents. Could smaller sharks have used this to their advantage? Maybe while megasharks were still little, they became a meal for great whites, as well as bull and tiger sharks. Even at those times, a great white shark could reach the length of 20 feet, while a megalodon kid was definitely smaller. But even if there had been no open confrontation between young megalodons and smaller grown-up sharks, meg kids wouldn't have been able to find food for themselves to grow to adulthood. The reason is the same. The population of other sharks was growing, and they were rivaling each other and the meg for convenient food. The more great whites and other sharks appeared in the oceans, the less food remained for young monster sharks. Eventually, they probably starved. But it's just one of the theories that try to explain why the meg went extinct, and here's another one. A new study has shown that the meg was most likely a warm-blooded predator able to regulate its body temperature, and that might have been the reason why this species disappeared with time. Scientists analyzed isotopes of the tooth enamel of the megalodon and concluded that the animal could easily maintain a body temperature that was around 13 degrees F warmer than the temperature of the surrounding water. Such a temperature difference is much greater than what other sharks living at the same time as the meg had, and it's large enough for the ancient predator to be classified as warm-blooded. These days, most fish are cold-blooded. Their body temperature is the same as the surrounding water, but some sharks, like mackerel sharks, keep the temperature of all parts of their bodies a bit warmer than the surrounding water. But it doesn't make them completely warm-blooded because they simply store heat generated by their muscles. And in mammals, body temperature is regulated by a special region of the brain called the hypothalamus. Anyway, the meg's warmer body allowed the animal to move faster, deal with cold water better, and spread out all over the world. But eventually, it might have led to a disaster. The megalodon lived during the Pliocene epoch, pronunciation. It began approximately 5.3 million years ago and finished 2.5 million years ago. During that period, global cooling occurred. It also caused the changes in sea level, which the megalodon probably didn't survive. The main problem for the predator was to maintain an energy level allowing its body temperature to remain elevated. But to do it, the animal had to eat a lot, and I mean it. But it was a challenging task in a time of changing marine ecosystems, and while competing with newcomers, such as the great white shark. If this theory is true, then the amount of energy the meg had to use to remain warm could have contributed to its extinction. This new information is very important to us. It shows that many marine predators in modern oceans might be experiencing the effects of ongoing climate change too. By the way, have you heard that there have been several cases when people were sure they had seen the meg? Or at least some similar extremely large monsters. And these sightings happened relatively recently. For example, in July 1916, the New Jersey coast of the US was terrified by a series of shark attacks. They happened during an oppressive heat wave when hundreds of beachgoers tried to find shelter from the heat near the water. People described the culprit that had caused all that havoc as a giant shark, much bigger than any regular one. Since then, scientists have been debating which shark species was involved in those accidents. The most popular guesses have been the bull shark and the great white. A picture of a huge shark roaming the Pacific Ocean not far from Guadalupe Island appeared in 1999. The creature was nicknamed Deep Blue. It could be distinguished from others by a wavy pattern separating its gray back and white belly. But even though some people claimed it could be the infamous megalodon, experts came to the conclusion it was a female white shark, the largest ever seen. The average length of a male white shark is 11 to 13 feet. Females are bigger, up to 15 or 16 feet, but Deep Blue reached more than 20 feet in length. No wonder people were confused. For the last time, Deep Blue was spotted in 2013 near the western coast of Mexico's Baja California. But look, there's another jumbo shark, and you can meet it in any part of the world. The largest specimens can reach 40 feet long and weigh about 5 or even 6 tons. Could it be, if not the megalodon itself, but one of its relatives? Again, a wrong guess. That's the basking shark. This animal prefers subpolar seas, with temperatures not higher than 58 degrees F, even though some of these animals do migrate to warmer places. Like whale sharks, basking sharks are harmless and don't attack snorkelers or divers. These creatures have loads of small teeth, but they don't use them when feeding. Instead, they swim with their huge mouths open and swallow plankton. A grown-up basking shark can filter nearly 2,000 tons of water per hour.
Not much happens in dark, murky ocean depths. It's mostly pretty quiet, with some smaller fish carefully passing by and probably hoping nothing big would grab them on their way. There's also a bigger fella looking for plankton coming through every now and then. Suddenly, a giant beast comes out of nowhere. First, it's just a dark dot in the distance, until it gets closer. Oh, it's a great white shark. You can recognize its firm dark gray body, white belly, and slanted head. These creatures have special cells in their skin called melanocytes that can make their color change to lighter or darker. This way, a shark can blend in with its surroundings, which is a nice ace up its sleeve and the reason why we barely even see one coming by. These predators can grow up to be more than 20 feet and weigh up to 5,000 pounds. Our fierce fella is just passing by looking for some lost fish that might wander around, if it gets lucky, directly into its mouth. But instead, a giant jagged tentacle comes out of nowhere. The great white barely escaped it, and quickly swam a little further to see what was happening. A giant squid comes out of the depths. Its eyes, as large as dinner plates, are looking straight at the shark, while its soft body is getting closer. A challenging prey, but hey, why not try? Most of the time, these creatures eat shrimp, fish, and other squid, but sometimes they like to really treat themselves, so they go after small whales. A shark will do too. I know you'd expect these creatures to be way smaller, or that's at least how I comfort myself when I swim a little further from the shore where my feet can't touch the bottom anymore. But they can weigh 600 pounds and be 40 feet long. The great white shark is the biggest predatory shark on our planet. Check out its long and sharp teeth. It definitely has the biggest smile down there in the ocean. Great whites have around 300 teeth, but they don't use most of them for biting. Instead, they have a special system where new teeth grow all the time because they need to replace the ones that get worn out or lost. And they have a really powerful bite, over 20 times stronger than ours. Considering all that, you might think a great white shark has nothing to be afraid of in the ocean. But looking at its gigantic enemy, we can't be so sure of that anymore. Octopuses only have 8 arms. Squids too, but they also have 2 additional tentacles. They're similar to their arms, but suckers on the arms go along most of their length, while tentacles have suckers only at the ends. This squid has probably hundreds or even thousands of suckers. There are squids without these suction cups, but in that case, they have rotating hooks, or a combination where these two work together. Hooks catch prey, and suckers stick on it so it doesn't get away. Squids have teeth too, plus they have this special part called a radula. It's like a tongue, but with teeth on it. The teeth are tightly packed together and are difficult to remove. When food is passed to the radula, the teeth chew it into small pieces. This is important because squids have sensitive body parts near their throat, so they need pieces of their food to be very small. Their bite may not be as strong as the great white sharks, but it's still quite powerful. For instance, way stronger than a lion's. They also have glands that produce venom and use their beaks and radula to inject the venom into their prey or a creature that's coming after them. Wow, these squids are really equipped better than expected. And they're also way longer than the great white, which gives the squid more room to attack it with its long tentacles from a distance and seize it. Giant squids usually live at depths of 2,950 feet, while great whites prefer to stay at depths of about 650 feet. But we'll try to keep the competition fair. Let's say these two meet in a territory where water pressure won't hurt or bother any of these animals. The great white is circling around the squid. It moves a bit faster than the squid. Its swimming speed can reach 25 miles per hour when the animal is submerged, and it also has short bursts of speed when it can move at 35 miles per hour. Giant squids move at around 25 miles per hour. Just for comparison, an average human swims at 2 miles per hour. But with its length, the giant squid has more room to attack the great white shark with its long tentacles from a distance. They can stretch for 33 feet to snatch the prey. And look, it's really trying. But it ain't that easy. Not only is the great white big and fast, but it also has special sensors called the ampullae of Lorenzini. It's a good tool to detect prey and generally stay safe in the ocean. But the squid is definitely no joke. It has activated its special defense mechanism and released thick black ink. The great white is confused. The ink is like a smoke screen, which gives the squid enough time to get away. The shark can't see its opponent anymore. The squid is getting closer, and the poor great white has no idea from which direction. It's time for the final move. Even if the great white manages to catch the squid can detach parts of its body as a last resort to protect itself. It can lose up to 10 body parts, unlike sharks. These predators can't lose any essential body parts because they won't survive. And look, the squid finally latches onto the shark. Its suction cups and the sharp beak that can pierce its prey make it nearly impossible for the shark to escape. They both disappear into a cloud of ink, the great white shark in one of the rare fights it can lose, and the giant squid ready for new conquests across the ocean. Aren't giant squids perfect for scary stories? In legends, there are often battles between humans and sea monsters. In the past, Norwegian sailors shared stories about sea creatures they encountered during their ocean travels. Over time, these stories grew to include creatures that were like giant islands with arms. And let's not forget about the Kraken. It's a legendary sea monster from Scandinavian stories that looked like an island, which was how it would trick sailors. The spooky stories say the beast was using its long tentacles to grab ships and drag them to their doom. And do you remember Jules Verne's novel 20,000 Leagues Under the Sea, which describes an encounter between a ship and a giant squid? In real life, giant squids don't eat humans, and they're not particularly interested in going after ships. However, not all the stories about these creatures attacking ships are made up. There are some reports. For example, in the 1930s, something attacked a Norwegian tanker, the Brunswick, 3 times. And yes, it was indeed the work of a giant squid. Fortunately, the squid couldn't grip onto the ship's steel hull, so it ended up getting caught in the propellers. But even though everything was okay in the end, just looking at this gigantic monster trying to take your ship down to the bottom must have been terrifying. we can laugh at stories about the Kraken until we're out there on our own. In 2003, a giant squid came closer to a French yacht that was participating in a sailing race. It couldn't cause any harm, so it eventually gave up. So, for now, the idea of a giant squid taking down a ship or boat remains a fictional story, although they're certainly capable of trying. Okay, giant squids are big, but there's another creature from their family of cephalopods that can be even larger. It's called the colossal squid, and one that was found weighed 992 pounds, hundreds of pounds more than the giant squid, 606 pounds. And they can stretch their tentacles for up to 45 feet.
Have you ever wondered what animals looked like when they first appeared in the ancient oceans over 500 million years ago? Well, scientists have been scratching their heads about this for more than a century, and now they believe that they finally found the answer. So let's take a look at their discovery. You see, our ancient ancestors probably lived 600 or 700 million years ago. They were soft-bodied, so unfortunately they didn't leave any fossils behind. Scientists decided to uncover the secrets of these ancient creatures by comparing them to all the animals that exist today. First, we need to ask ourselves, what is an animal? Well, we know that they're incredible creatures with heads, innards, muscles, and brains. And we know that humans are part of this animal gang too. We're called bilaterians, and we have all these cool features that evolved around 500 million years ago during the Cambrian explosion. But there are also awesome creatures with very simple body plans. We've got jellyfish, sea anemones, sponges, ctenophores, and many more. They may not have fancy brains or muscles like us bilaterians, but they still have the essential qualities of animal life. For example, they develop from fertilized eggs into living beings. So, researchers decided to take a look at them to figure out which group was the earliest branch on the tree of life. To solve this mystery, they used a technique called DNA sequencing. They looked at the genes of these animals. The similarities and differences in the genes helped scientists understand how creatures are related and how they evolved. By comparing DNA, scientists could piece together their evolutionary family tree. The list narrowed down to two candidates: sponges, which are basically lazy filter feeders, and comb jellies, which are fierce predators cruising through the oceans. But the controversy remained: who came first? Sponges may seem to be simple fellows. After their free swimming phase, they settle down and filter tiny food particles from the water. No nerves or muscles for them, but their hard parts make excellent scrubbers. For a long time, scientists believed that sponges were the very first branch of the animal family tree. They thought that before anything else, there had been these tiny single-celled creatures called protozoans. Then these protozoans came together and formed colonies that eventually evolved into sponges. And from there, sponges became the ancestors of all animals, including humans. But hold on. Meet the comb jellies, those mesmerizing creatures you often see in aquariums. They may resemble jellyfish, but they're not even close relatives. Instead of squishing through the water, ctenophores use rows of beating cilia, like combs, to propel themselves. You can spot a sea gooseberry, a common ctenophore, along the California coast. It's about an inch in diameter and quite fascinating to observe. Anyway, now we have two contenders. To find out whether sponges or comb jellies were the first, the biologists turned to an unexpected superhero: chromosomes. You see, each species has its own unique chromosome number and gene distribution along those chromosomes. For example, humans have 23 pairs of chromosomes. So scientists didn't just look at the genes each animal had, they also checked where those genes were located on their chromosomes. You see, as animals evolve, their chromosomes rearrange, and genes move around. Once they move, it's really hard for them to go back to their original spots. So, the clever biologists figured that the animal with the least shuffling of genes on their chromosomes must have appeared first. They basically had to find a puzzle with the least shuffled pieces. To crack this mystery, the scientists compared the gene placements in sponges and comb jellies to their closest single-cell non-animal relatives. These single-cell relatives were like cousins to the first animal and held clues about the original genome. The closer an organism's genome was to the original, the less it had changed and the more likely it was to be the sister. So the research team discovered something incredible. Despite more than 500 million years of independent evolution, sponges, jellyfish, and many other invertebrates share similar sets of genes on their chromosomes. It basically meant that animal chromosomes evolved slowly. It also gave the researchers a golden opportunity to digitally reconstruct the chromosomes of the ancient common ancestor. There was another big problem, though. We had no idea what the chromosomes in comb jellies looked like until the year 2021. That's when brilliant biologists finally cracked the code. They discovered the chromosome structure of a particular comb jelly with a pretty complicated name. Yeah, I'm not even going to try. Anyway, let me tell you, it was like nothing they had seen before. Strangely, the chromosomes of these comb jellies were totally different from the chromosomes of other animals. The scientists were perplexed. Is it because they had changed a lot over millions and millions of years? Or is that because they actually appeared before all other animals? It took scientists some time and a lot of hard work to fill in those missing pieces. And guess what? Finally, they found the answer. It turns out the first branch of the animal tree belonged to comb jellies. Sponges came next, and then all the other animals, including us humans. So let's discuss this little funny creature from which we all originated. Jellies, including comb jellies, are simple creatures with few specialized organs. They can sense chemicals in the water to find their food, and they even have a special structure called a statocyst that helps them orient themselves in the water. Comb jellies are also known as ctenophores. They're cute little creatures that live all around the ocean, from the North and South Poles to the sunny equator. They can be found from the surface all the way down to the deepest part of the sea. These amazing animals belong to the group of invertebrates, which means they don't have a backbone like we do. They come in various sizes depending on the species. And by the way, despite their extraterrestrial appearance, their soft bodies are perfectly designed for their underwater world. They're more than 95% water, which makes them lightweight and agile. Comb jelly is a fascinating creature with an oval shape and 8 rows of tiny comb-like plates. It uses these combs to swim gracefully through the water. And guess what? When it moves, its combs create a magical rainbow effect as they diffract the light. It's like swimming through a shimmering prism. But they aren't as cute or harmless as they seem. In reality, comb jellies are voracious predators. They love to feast on other jellies, and some of them can even stretch their stomachs to hold prey that's almost half their own size. So, their diet consists of other comb jellies, as well as some salps and siphonophores. Talk about having a big appetite. And here's another interesting fact. Even though comb jellies got a head start in branching off from the tree, both they and sponges have been evolving since then. They've been on their own journeys, adapting to their environments and developing new features over time. It's a reminder that evolution is an ongoing process. It also shows how important it is to take care of these unique creatures and their environment. Changes in jelly populations can be a sign of bigger issues, so it's crucial to protect their habitats. But why is all this so important? Well, these discoveries help us understand how animals have developed. By studying the early branches of the animal tree of life, we can understand about the characteristics and traits that all animals share. For example, how they sense their surroundings, eat, and move. We can also learn all sorts of cool things about how animals first emerged and evolved into the wondrous array of species we have today. The scientists were really excited about their discovery. They knew that they had found a relic from a very ancient time. So, there you have it. This discovery is like a magical time machine that allows us to peer deep into the past. It's a treasure trove of knowledge about the origins of animal life. I'm sure scientists will find out more interesting things in the future, so stay tuned.
Look at this pretty creature. It looks cute and totally harmless. But you should know that appearances are deceptive, and the blue-ringed octopus is an extremely venomous species of octopus. In fact, they are one of the world's most venomous marine animals. These creatures are found in tide pools and coral reefs. Despite their small size, a mere 5 to 8 inches, they're very dangerous to humans if provoked. Their venom contains a powerful neurotoxin called tetrodotoxin. When the animal feels threatened, its first instinct is to flee. But if the threat persists, for example, if you don't give up the idea of picking the octopus up, it will go into a defensive stance and display its blue rings. If the octopus is cornered and touched, it may bite its attacker, and it can end very, very badly. Tetrodotoxin causes severe consequences, and sometimes results in total body paralysis. When the victim is fully aware of the surroundings but unable to move, the victim remains conscious and alert, but because of the paralysis, there's no way of signaling for help or indicating distress. Interestingly, in its chilling mode, the blue-ringed octopus looks brown or even pale, but once it feels endangered, it switches on its psychedelic pattern. Such a response is called aposematic behavior. In simple words, it's when an animal flashes bright colors warning others that, should they take a bite, they won't live to tell the tale. Of course, the blue-ringed octopus isn't the only dangerous animal that looks harmless out there. For example, look at this creature. This animal looks super cute, fluffy and soft-looking. The desire to touch it is irresistible. Watch out. The sting of the hairy caterpillar can pack a serious punch. It's called the puss moth caterpillar, or asp. Hidden among that luxurious fur, there are venom spines equipped with stinging cells like jellyfish. People react very differently to caterpillar toxins. Some may develop more severe reactions than others. Plus, how bad the consequences are also depends on the thickness of the skin in the affected area. In most cases, the unpleasant sensations and rash go away in a few hours or sometimes days. The next animal on our list is the poison dart frog. There are more than 170 species of these frogs, and funnily enough, not all of them are actually poisonous. Those which are secret extremely dangerous toxins through their skin. On the bright side, the frogs never use these toxins for hunting or attacking. They only have them for self-defense. Experts aren't sure, but they suppose that the frog's ability to produce these toxins might come from a diet rich in toxin-containing animals, for example, centipedes or ants. Indigenous peoples in Central and South America have been known to rub their arrows and darts on the frogs in order to give them a poison tip. The main thing you need to keep in mind: if you touch a poison dart frog, seek assistance immediately. Especially if you've come across the golden poison dart frog, it's the most toxic one. The flamboyant cuttlefish is the only known venomous cuttlefish species. This creature has incredibly poisonous muscle tissue, despite its tiny 2 to 3 inches at most frame. Watch out for a dark brown underwater animal with 2 tentacles and 8 arms. It's also likely to have purple and yellow around its arms. Anyway, your best bet is to avoid biting into one of these intriguing creatures, and you'll most likely be safe. Predatory cone snails are very slow animals. This is the main reason why they have no means to capture their prey mechanically. I mean, they can't really grasp another animal or bite it. Instead, the cone snail has evolved potent venom that helps it survive. Probably the coolest thing about these creatures is that among almost 1,000 species, there's no overlap in the toxins produced by each of them. Even though cone snails don't have fangs, they have a venom-covered harpoon they use to sting their prey. There's a tube-like structure at the end of a venom bulb, and a modified tooth can shoot out of the tube at a mind-boggling speed of 400 miles per hour. So being slowpokes doesn't actually bother cone snails. And since the venom is unique to certain species, some of them can deliver a minor sting, while others might cause serious harm to your health. For example, this reef-dwelling little fella unleashes a harpoon-like tooth to sting its prey, and there is no known cure for its venom. When you think of pufferfish, you probably imagine a bloated-looking creature with impressive 360-degree quills. But beneath those funny spikes, there is a vicious creature. And the most dangerous part of this creature is its poison, which is considered to be one of, if not the, most dangerous and potent in the world. The good news is that you won't get poisoned unless you eat the fish. So maybe better stick to the California roll. Now look at this insect and try to never approach it. It's the Japanese giant hornet. This monstrously sized creature, which can grow to be almost 2 inches long, is known to be highly aggressive. Its impressive stinger packs enough venom to make the sting very, and I mean it, painful. Some people don't survive being stung by this insect. Even though the venom isn't the most potent, the large size of the creature makes the dose too big. And if it's not one but several hornets attacking you, well, the consequences are likely to be dramatic. The giant hornet isn't necessarily unfriendly toward people or other animals, but it will sting if you provoke it. This truly beautiful bright blue creature is called the blue sea dragon. Despite such an imposing name, the critter is actually tiny, usually no bigger than a grape. You may find it on the beach or floating beside you in the water. Now, you need to remember one thing. However pretty this little slug may look, never ever touch it. Despite their tiny size, their sting can pack a punch, all because of their diet. Their favorite dish is the Portuguese man-o'-war, a jellyfish that has enough venom to paralyze small fish and crustaceans. The blue dragons first use mucus to neutralize the jellyfish's infamous stinging cells, and then they steal these cells from the man-o'-war's tentacles and store and concentrate them within their own tissues. Then they release these stinging cells on contact, which makes their own sting even more powerful, even worse than that of the man-o'-war's itself. These awesome creatures are also extremely sneaky. Even though their appearance is bright, to say the least, they're well-known masters of disguise. You see, that vibrant blue coloring is actually on their bellies, and when they float on their backs, they simply blend with the water. As for their backs, they're gray to camouflage these animals on the sea surface. The Irukandji jellyfish, found in Australia, looks tiny and totally innocent, but appearances are deceitful, and this baby, the size of a human thumbnail, is actually extremely dangerous. During stinger season, which lasts from November to May, tons of beaches get closed because of these itsy-bitsy creatures. What makes the jellyfish particularly dangerous is their miniature size. People simply fail to notice them while swimming. The infamous box jellyfish, named for its cubic body shape, lives in the Indian and Pacific Oceans. Stay away if you spot a creature with a squarish bell and long, dangling tentacles. And even if you only see a single tentacle without the jellyfish attached to it, don't come close or touch it. The box jellyfish can grow up to 10 feet, and each of its tentacles has about 500,000 microscopic harpoons to inject venom. Unlike other jellyfish, box jellyfish are hunters. They can latch onto you by wrapping their slender tentacles around your limb or body. With how dangerous their venom is, it won't be a pleasant experience.